Good morning, dear students. Today we are going to study about some of the topics in engineering mechanics. First unit is introduction, statics of particle, introduction, units and dimensions, laws of mechanics, Lamy's theorem, parallelogram, and triangular law of forces. Then vectorial representation of forces are vectorial representation of forces, vector operations of forces, addition, subtractions, dot product, cross product, coplanar forces, rectangular components, equilibrium of particle, forces in space, equilibrium of particles in space, equivalent system of forces, principles of transmissibility. The outcome of this unit 1 is we are going to apply the Newton's law of mechanics to the to solve the problems in engineering mechanics mostly relevant to the statics. These are the two reference books we are going to follow for this course. And these are the reference books we are going to follow for this course. These are the NPTEL references we are going to use additionally for this course. Okay, we will move on to the topic. Now you are looking at the tallest building of the world, Burj Khalifa. Uh, to design this building, we have we have to know the knowledge of statics. This building may be subjected to static loads and dynamics loads. The effect of these loadings on this building will be studied in this course. To understand the effect of forces on this building, we need to know the engineering mechanics course. What is the mechanics? Mechanics is a science that describes and predicts the conditions of the rest or motion of the bodies under the action of forces. For example, when we are applying a force on an object, the object may be in a static condition or continue to be in a static or started moving or in a dynamic conditions. Here we are analyzing or we are finding out the effect of forces acting on the object when the object is in static condition or in dynamic conditions. Mechanics is further classified into mechanics of rigid bodies, mechanics of deformable bodies, and mechanics of fluids. Mechanics of rigid bodies further classified into statics, dynamics. Mechanics is an applied science, it is not a pure science. Since we are going to apply the concepts or laws studied in the mechanics to the real-time applications, so it will not come under the pure science courses. This course forms the prerequisite for the courses like fluid mechanics, strength of materials, design of transmission system, design of machine elements. So it is needed a better understanding to study the future courses. Why we have to study engineering mechanics in a view of both statics and dynamics. Here I am having a few examples. For example, we have a bridge. We need to find out the how much force will be affect how much force the bridge can withstand when the vehicles traveling over the bridges. We need to know the knowledge of engineering mechanics. For example, another one more example is dam. Dam is used for storing the huge amount of water. The fluid pressure will be acting on the walls of the dam. So we need to understand the concepts of statics to understand the forces acting on the walls of the dam. We are used to do crane. We are using cranes for construction purpose or material handling purpose. The crane hook, how much weight can crane hook lift without damage or without breaking? That to find out the answer for these questions, we need to study the engineering mechanics courses. In case of dynamics, we have a few examples. To know the flight characteristics of a jet, design a building to resist earthquakes, and mitigate shock and vibrations to passengers inside the vehicles. These are a few examples that why we have to know the dynamics of particles and dynamics of rigid bodies. There are four fundamental concepts in engineering mechanics: space, time, mass, force. In these three, space, time, mass are independent of each other, but the force is dependent on mass and the acceleration. This force is a dependent quantity. Force is a vector quantity which is having both magnitude and directions. It is characterized by the point of applications. Three important points: point of applications, magnitude, and direction. Space, it usually represents the three-dimensional plane. Plane, the term used to represents the two dimensional. In space, if we have a point, the point will be the location of the point will be shared by find location of the point or coordinates can be find out by finding the x, y, z coordinate values. In planes, we need only two values x and y, or xz or yx, to find out the location of the points. Another one concept is difference between the mass and weight. Mass is a property of matter that does not change from one location to another, whereas the weight will change from one location to another location based on the gravitational attractions. W is equal to, the formula for weight is W equal to mass into acceleration. Sorry, mass into gravitational acceleration, mg, acceleration due to gravity. The flowchart represents the classifications of engineering mechanics: mechanics of solids, mechanics of fluids. Mechanics of solids is further classified into mechanics of rigid bodies and mechanics of deformable bodies. Mechanics of rigid bodies contain further classified into statics and dynamics. Mechanics of deformed bodies classified into theory of elasticity and theory of plasticity. Mechanics of deformable bodies will be studied in the course of strength of material, and mechanics of fluids will be studied in fluid mechanics and machinery. In dynamics, is further classified into kinematics and kinetics. In kinetics, we are not considering the forces which causes the motion. Our focus in kinematics only will be the velocity and acceleration. These two parameters we are going to focus on kinematics. In kinetics, along with velocity and acceleration, the forces causing the motion also considered are taken into consideration for the problem solving. That is called as kinetics. There are few idealizations in mechanics. These idealizations are used for better problem solving. Continuum. Continuum means the mass. Every object is made up of atoms and molecules. The atoms and molecules are uniformly distributed throughout the particle. that is called as continuum. But in real time or real objects, it is not the case. We have voids or empty spaces. But for solving problems in engineering mechanics, we are using this assumption. For all the objects, in all the objects, the masses are distributed equally in all directions, so that we can have the same answers throughout so that we can have the answer for the entire structure, not for the particular point or particular region. Another idealization is a particle which is not having any dimensions or negligible dimensions, we can say. A body with mass but with dimensions that can be neglected. We can have an example like this. In a solar system, we have an earth. The size of the earth is insignificant compared to the size of its orbit. In that case, to know further studying if our focus is only on the earth, then we can consider the earth as a particle with respect to the orbit size. Earth can be modeled as a particle when studying its orbital motions. Rigid body. Rigid body, a combination of a large number of particles in which all the particles remain at a fixed distance from one another before and after applying a load. This assumption, but in real cases, there may be when we are applying a load in a rigid body, there is some deflection, but these deflections are very much negligible. So, or it is relatively small, so we can assume all the structures are rigid bodies, and we can use these assumptions for the analysis purpose. Then we will move on to the Newton's three laws of motion. First law. First law contains the principle of equilibrium of both forces. The statement for the first law is: a particle originally at rest or moving in a straight line with constant velocity tends to remain in its state provided the particle is not subjected to an unbalanced force. Newton's first law gives the definitions for the word equilibrium. When an object is kept at rest or it is moving in a straight line path with a uniform velocity, unless it is disturbed by an external force, it will continue to remain in its path for a period of time or for an indefinite period of time. It is a Newton's first law. Newton's second law. Newton's second law, which gives the definition for the force. Force is equal to mass into acceleration. Force is dependent on mass and acceleration. If we are applying a force on a particle, the particle moves in a straight line path with an acceleration. The mass of the ball or mass of the object multiplied by the acceleration, which give the force. The unit of force is 1 Newton. In CGS unit system, it is represented as 1 kg 1 kg meter per second. That represents for to move the 1 kg object at an 1 meter per second acceleration, we need 1 Newton force. This equation is useful in solving the problems in related to dynamics. Newton's third law: the mutual force of actions and reaction between the two particles are equal, opposite, and collinear. Every force has an equal and opposite reactions. We will further discuss the remaining topics in our next videos. Thank you.